Well, hello guys, welcome back to John's Workshop, and in this video we're going to be doing workshop tips number 7. And I know this is coming quite quickly after number 6, but opportunity has arisen for a particular job that I've got to do, and also I'm addressing some of the comments I've had from previous workshop tips videos in that series where people have asked me could I do a video on planning for manufacturing or planning for machining, based on obviously my industry experience that I've had, and work experience and things like that. So that's what this video is going to be about. And so basically we're going to go through just some general rules around manufacturing process planning, as it's sometimes known, or planning for manufacture. Have very different names depending on which industry you come from. We're going to talk about industry itself, so I'm going to just do a quick reflection on how I've learnt this, and through my career and through the various stages of my career, how that's changed in industry. Then we're going to focus in on the home shop and see what we can read across from industry, from that industrial thinking into the home shop, which bits read across and which bits don't. And then we're going to go through a worked example. As I said at the start, I've got a part that I need to manufacture, so any of you that are following along on my mill head refurb series that I'm doing will have already seen the video where I've messed up, we'll use that word, the spline on the quill pinion shaft, so I need to make a new one of those. So that's quite a complex-ish part, it's quite big. There's a few different types of operations in there, obviously gear cutting, turning, threading, there's quite a few different things in there, so a good worked example. And then as we get to the end, we'll just do some general reflections and just a bit of a reminder of the key points really. So without any more babbling, I'll wipe the board, we'll put some different stuff on, and I'll bring you back and we'll start digging in to planning for manufacture. Okay, so we're just going to go through some general rules for manufacturing process planning, or planning for manufacture, or the other multitude of names that this may have. And these are taken from my industrial experience. So most of you know I've spent many years in aerospace, in large industries, now currently in shipbuilding, in heavy industry, and prior to that many years in subcontract industry for many different companies. So that's my background. So I've been in lots of different arenas, but largely I've had to think about what are the key things that are common across all of those different arenas. So we'll touch on the first few. So when you're planning a job out, you've got to be thinking about what's the most efficient route. So what's the most efficient route to get my part through the workshop, through the factory, through whatever it is, through the shipyard. It doesn't matter where it is, it will go through multiple operations. What's the most efficient route to get that material through? So in a large factory, you really wouldn't want to be, and this is a lot about factory planning more than part planning, but you wouldn't want to be going in one shop and then out of that shop into the shop at the other end of the site and then back to the first shop again and things like that, because there's lots of material transport in between, very inefficient. Or similarly going out to subcontract operations, things like that. So in industry, that's a real key thing. It's no different in a home shop. What's the most efficient route? And the reason I'm saying that, so in industry that's all about money and profit. In the home shop, profit is time. It's a hobby. This is a hobby for us all. I'm time poor. I've got a full-time job that's quite demanding, a house, everything else, so have many other people. So physical workshop time is my profit, if you like. That's my enjoyment time. I don't get a lot of it, so I need to try and make the best of it. So what I don't need to be doing is wasting any time through poor planning. So it's all comparable from industry to the home shop. Least material waste, again, in industry, all about profit, all about money. So there's no point trying to machine something out of a 100mm or 4-inch diameter slug of material that's going to finish up 1-inch diameter or less, 25mm or less diameter. That is just really wasteful in both materials, time, tooling, electricity, power. There's a whole load of waste in there. So again, it's about material selection, making sure you're selecting the right materials. Least number of setups, very obvious. Thinking about right from the start, how am I going to hold this from the very first. So which operation is going to come first? Do I turn it this way round first? Do I turn it the other way round first? When it goes on the mill, do I mill it horizontally or vertically? Is the mill the right, the right machine? It's that thinking about what is the least number of setups that I'm going to have to use, because every time you've got a setup, you typically add an hour, probably in certainly in industry. To set a big industrial machine up, it'll be an hour largely to do a full setup or more. In a home shop it might be slightly less, but again, going back to your currency of time in a home shop, that could be your entire evening or weekend just doing a setup. So if you've got 10 setups more than you need, you just lose that time. So minimizing post work, what I mean by that is planning your machining out so you've not got lots of deburring to do, lots of polishing to do, lots of anything like that that comes after you've finished machining. So when you take the part out of the lathe or out of the milling machine or whatever other machine it is, you're not having to spend lots of time with a file or with emery cloth or with whatever else it is to get it how you need it. So thoughts around that, and all of those are grouped together under a pound banner or a dollar banner or whatever currency you're in. That's all about money, and in the home shop example, all about time. And then we go to the opposite end of the spectrum, which is all about quality. So, and I've said there, achieving 100% RFT, which is industrial speak for right first time. That basically means hitting all the numbers, getting it right first time, not having to do lots of rework, not scrapping it and having to start again. So it's thinking about how you're going to plan to minimize the risks of getting it wrong, basically, on terms of dimensional measurement, surface finish, anything else, any other restrictions that are implied through your drawing, if you're working to a drawing or your plan or your previous part that you're copying. All of that needs to be thought about. Distortion or any post heat treatment ops, again, that's linked to material selection. So you could say, I've picked what we call a near net forging, something that only leaves me 0.5 millimetre all round, and then, oh, we've got to send it out for heat treatment. Oh, it's come back from heat treatment. Guess what? I've not got enough stock left on this now to machine it because the thing's bent, twisted, warped during a hardening process or a stress relieving process. So again, it's balancing off the two of least material waste with I need enough material to account for any distortion that I'm expecting to get, or any post-process heat treatment, things like that, that could change the structure of the material. And I'm saying here the best route, which is significantly different in every case to the most efficient route. So the best route might be, I've got a surface finish to hit, and I could mess around in a home shop for an hour trying to hit that surface finish on my milling machine and fail, whereas if I put it on my surface grinder, I know I'm going to get it, but the surface grinder is going to take 10 times longer to get the material to where it needs to be. So costs money but achieves the end result that you can guarantee it. So it's least risk option and the best route. And again, coming from industry, and it's no different in a home shop, the safest route. And typically in industry, that's the first thing you consider when you've got a workforce working for you. You want to make sure that they're all safe in their day-to-day work. So that adds cost. Safety adds cost, and safety considerations adds cost. And it's the same in a home shop. Your currency is time in a home shop. Therefore, working safely and in a safe manner takes time. You've got to think about, am I putting myself in danger? Am I risking any of my machines? Which again adds cost. So it's all that around safety. And these are the kind of, there's loads. I could write loads and loads and loads and get into tons of detail, but these are the key things that I think are common through all the different industries that I've been in. So I could go on waffling for ages and ages about this. I think I've kind of covered that. So we're now going to move on to a little bit more about industry and about how manufacturing process planning or planning for manufacture is done in industry based on my experience in the industries that I've been in. Okay, we're just going to have a quick look at industry. So, and again, I've tried to think across the range of my industrial experience, again for the common themes. So the first point I've thought of there is good planning always starts at the desk or the bench. And it's the bench if it's a very small manufacturing firm. You sit down at the bench with the drawing or with the sample part and you plan everything out ahead of time on the bench. You think about all the moves, all the setups, all that kind of thing. You have to do it on paper first to get good planning. What you don't do is go, I've got a 50mm 2-inch diameter bar, my finished part ends at 30mm or inch and a half, whatever it is, therefore I'm just going to whack it in the machine and just plough a load of material off to get somewhere near where I need to be before I start thinking about what I'm doing, because that will inevitably end up in, probably, you find out that you've taken material off where you need material for a later work holding area. You've got far more setups, because if you'd thought about it first, you could have done that as part of one of the other operations in the mix. So you start to add in all of those, you start to add in more multiple setups, you start to need more tools and everything like that. So good planning always starts at the bench. So bench for a small industrial environment, and desk for a big company where you're probably programming CNC machines, things like that. And I'm thinking across the range of my career. When I started, and this will probably make you laugh, when I started on my very first CNC experiences, we used to photocopy the drawing to get the outline of the part. We would draw around that then with pens and pencils in terms of the stock sizes. We would then cut out scale models of the tools and colour them in with coloured pencils, and then you'd start drawing all over your paper with different coloured bands to show red for the red tool and green for the green tool, and just planning out where your tools are going to come in from, where they're going to finish up, what's your most efficient cutter paths, things like that. For CNC machining, it's no different for manual machining. You don't go to the cutting out bits of paper bit, but yeah, it's about that forward planning, forward thinking, and good planning. So vitally important. Lay the job out on paper. We just discussed that. Whether you're doing it for a CNC machining industry or whether you're doing it for a small, workshop in industry, draw it out, sketch it out. You see me do it on the whiteboard. I often do that. Lay it out on paper, stare at it, understand again where you're going to hold, when you're going to hold, why you're going to hold, which tools you're going to use, why you're going to use them at that particular point. It's that forward thinking, forward planning is vitally important to, and it might feel like, actually, if I just chuck the material in the machine and start cutting, I'm going to be quicker, I'm going to get to the end. No, you're not. That hour spent, or a couple of hours spent, depending how complex the job is, laying it out on paper first, you will save that 3 or 4 times over when you actually come to machine the part. So it's that forward thinking, forward planning, very important. And again, I've already touched the bottom 2 points. Understand your tooling, understand your work holding. For each particular operation you're going to do, to understand that most efficient route versus that best quality route. And some of the best machinists and some of the best manufacturing engineers that do this in industry, which is where I've spent most of my career in manufacturing engineering, are able to strike the right balance between cost and quality, and that's a very difficult balance to get right at times. So yeah, they're the key things to good planning. And then verify. So again, before you get to your machine, again talking about industry now, you would verify that what you've done is right. And in a small manufacturing facility, you do that with one of your peers, somebody else that you trust, that's got a good solid background. Hey pal, just come and have a look at this, check this over, tell me what you think, does that look right, is there a better way of doing it? That's a really good verification. In industry, there are lots of tools, especially nowadays in CAD/CAM world, where you can load up your thinking into that CAD/CAM world, and you can hit play and you can get a very visual graphic representation of what you're planning to do, and you can spot the errors before you actually commit to a machine. So that's industry. And again, I'm generalizing here, but everything that I've said there is equally applicable in the home workshop, just to a slightly different standard. Okay, so we're just going to have a quick look at the home shop now, and so how everything that we've already spoken about absolutely translates into the home shop in some form or another, and we've discussed some of that already. So what's different about the home shop to an industrial environment? So know your constraints. That's absolutely key. So understand when you're planning the job out, what depths of cuts my machine's happy taking. what tools work best in the machine, which, and if I'm thinking from a quality perspective now, which of my revolving centres is the most accurate, or which is the right shape for the features that I need to get into. There's so many things I could sit here and try and brainstorm, or stand here and brainstorm to try and throw on the table, but it's those types of things. Understand the constraints that you've got in your workshop, and the second point is plan around those constraints. There is no point planning out when you're doing the paper exercise on the desk or the bench first. There's absolutely no point planning around what you've seen somebody else do on YouTube or anywhere else or in industry, because their setup will be different to yours. So it's really important that you plan around your own kit, your own tooling, your own constraints, your own skills, your own confidence. There's a whole load of stuff that falls into a constraint bucket there. So think about all of that and plan around your constraints. And again, going back to the safety, we mentioned safety earlier. Safety is a constraint. You know, is it safe to have that part sticking out the lathe that far? Think about all that stuff. Okay, so, and plan around those constraints. Absolutely crucial, this next one for the home shop. Do not start the job unless you've been and eyeballed absolutely everything that you've thought about in your planning. There is no point starting the job. There is absolutely no point going, I'm pretty sure I've got a 17-30 seconds reamer. I'm sure I saw one once. And you've got your part neatly set up between centres. You've spent a lot of time getting it set up. Go to your reamer drawer, only to find that you don't have a 17-30 seconds reamer. Therefore, you've now got to go and order one. You don't want to take the part out of the machine, so you stopped. You stopped, and for the home hobbyist, it's all about having fun, enjoying your time in the workshop. Your enjoyment's finished at that point. All you've got to now do is go and spend some money and sit and wait for it to arrive. So do not start the job unless you've eyeballed every single bit of tooling, fixturing, everything that you need before you start the job. Now, I break these rules on a regular basis, as I'm sure most people do, but it's really important to think about these. You will enjoy, especially in a home shop, it's all about enjoyment, and you will get far more enjoyment out of a successful job that runs start to finish without any hiccups, because you've done that forward planning, forward thinking up front, than it is chucking something in and cracking on with it and then realizing, oh, I've not got this, and then that leads on to this next one, which is the most important one on the board for me, which is follow your plan. So there is no point investing that effort and energy up front to plan your machining processes out all the way through, and then the minute you hit one of the hurdles, because you've not planned around your constraints, you've not got the kit that you need, you then detract from your plan, and it's at that point everything goes pear-shaped very quickly, because you start, you've planned this thing from beginning to end, and the minute you detract from that plan, all of that planning and thinking goes out the window, and you're playing catch up for the rest of the job. And you might be successful, you might get it through, but yeah, follow the plan. And if you can't follow the plan, stop until you can follow the plan, would be my advice. So what we're going to do now is move on to a worked example. So I've got some raw material that has come in today, which is here, which is going to be for replacing my quill pinion shaft that I messed up. And I'm going to take some measurements first. I'm going to get my drawing up on the board, and then I'm going to do my planning almost live. I won't be doing all of it, but I'm doing some of it to give you an idea of how I will think about this job in terms of that upfront planning. Okay, we're just going to move into a worked example now. So I think, as I previously said, I need to make a new quill pinion shaft for my milling machine, because I made a mess of this one. So this is my finished part, this is my stock. So that's my starting position to make one of these. Now, because this diameter and this diameter need to be absolutely concentric, because they're two bearing diameters that are each side of the head location, that forces me down a particular route, because I'm not going to be cylindrically grinding this thing, I'm going to be turning it. So really the best way to achieve that is turning between centres. So I've already got a constraint that I need to work around there. So I know that two of my finish turning operations, which is going to be half of the part in one direction and half of the part in the other direction, is going to be done between centres. So that's the first thing I'm thinking about. The next thing I'm thinking is I've got to put a centre in each end before I can do that, so therefore this thing has to go into a 3-jaw chuck. So then I'm thinking, well, rather than try and waste all of this material away between centres where you've got to be a little bit careful because you're not gripping particularly tightly and you don't want to upset your setup, whilst it's in the 3-jaw chuck, I might as well rough this all out one side and then I spin it round to face off and centre the other end, rough out this end of the part. So that's my first two kind of machining ops already done. In terms of tooling, I'm going to be using a standard CNMG tool for doing that, for facing and for turning, because it's one tool change, one tool does everything, don't need to do any tool changes. Centre drill in both ends, that can stay set up in the tailstock while I'm doing this. Then we'll remove the part from the chuck, we'll set up our dead centre in the chuck and turn that to a 60-degree point. We'll put our rotating centre in the tailstock and we'll put this part back up between centres. Now, one thing I didn't say, while this thing's in the chuck, if I'm going to rough this out ahead of going between centres, I'm going to rough this end first. So we're going to rough that end first and then we're going to rough this end second. And why is that? Well, very simply, this is a much more stepped diameter and it's a much smaller diameter. So whilst I'm roughing this end out, I can be holding on this end, which is a much bigger diameter, therefore much more stable, much more sturdy, and it's a much plainer diameter, so far easier to hang on to in the chuck while it's in the chuck. So just already starting to think about most efficient routes, most stable setup, that kind of thing. So that's what we'll be doing there, and we'll be probably following that same 1 and 2 when we do the finish turning between centres on the lathe, for no other reason than it's a mirror of what I've already done probably. Once we've done the finish turning, we will then take the part off the lathe at that point. So all the turning is done except for this counter bore in here and this thread and this thread here. So what I might do at that point is put it back into the chuck. I'm just thinking this through now. Probably put that back into the chuck at that point on the lathe, yeah, and we'll do these two features. Now in the chuck they'll be fine. If these are slightly eccentric, it really doesn't matter. If these are 3 or 4 thou eccentric in the 3-jaw chuck, for what they are, it's a screw thread with a counter bore as a hold down for the handle on one end and for this coil spring on the other. If they're a few thou eccentric, it really doesn't matter. So that's the way we'll be doing this. So I would not be putting those holes in first and then trying to hold between centres. So that is another setup. I guess I could try and put the holes in first and then hold between centres on screw threads, but that's never a good idea because you're going to roll the top corner of your threads over at each end, which means you've then got to follow on with a secondary tapping operation to try and clean those back out. So we'll for the sake of an additional setup each end in the 3-jaw chuck, we'll put those two setups in. We'll then move over to the mill. Very similar to the setup you've seen in my previous video when I was trying to recut the splines. We'll be holding in the chuck and with the tailstock in this end while we do the gear cutting, and then what I'm probably going to do is, if I can still do that at that operation, I shall rotate the part round until this keyway and this hole are at top dead centre where I want to put them, and while we're still in that same setup I shall be putting that keyway in and that hole in on the milling machine. So it's one setup basically. So really that's the whole part at that point. There's nothing else to machine, so that's the whole part done in 1, 2, 3, 4, 6 setups in the lathe to do all the turn features, or 6 change rounds, and 1 setup in the milling machine to do the gear cutting, the slot and the cross hole at that end, which for a part of that complexity, that's not bad. And I'm not counting the setups between each gear index, because that's all part of the gear cutting operation. So 8 setups in total. I could rationalise that down to 6, as I said, by putting these holes in up front and holding between centres, but I risk damaging the threads, the lead threads at each end, which I don't want to do. So therefore I'm happy for the quick whip round in the 3-jaw chuck for how long it takes. It's not a big setup, therefore I'm happy. So that's really my thinking, and I thought I'd be talking for far longer, but that is what I'm thinking. I guess in terms of tooling, I said the CNMG tool for the roughing out, that's fine, and I'll show you that in the video when we do that. For finish turning this diameter here on the top of the gear crown, I don't know whether you can just make that out on the part, but there's a bevel here, looks to be about 45 degrees, need to measure that. So when I'm finished turning the gear OD diameter, I shall be using a 45 degree tool to do that, so I get that 45 degree feature and the OD, and I can also chamfer this corner, chamfer, all in the same operation while that tool's in the tool post. And so yeah, largely 2 tools to do all the turning. I may need to go to 3 if I'm not getting an adequate surface finish, especially on the 2 bearing diameters where it matters. I may need to switch my tools round for a second tool change, but largely 2 tools for all the turning. And from a milling perspective, I'm going to need a tool for that keyway, a drill for that hole and a spot drill, and the gear cutter for machining the gears in. So not very many tools really, and not that many setups for a part that's reasonably complex. So I hope that's been helpful. I just thought I'd walk through my thinking on that. Now, just one last thing I want to point out. Everything we spoke about earlier on in this video, where I did the industry comparisons, talked about the home shop, did all that other stuff, all of that stuff is absolutely common to any job in any workshop. It's all common points that run across everything. What I've just run through here in my worked example of planning for manufacture is only specific to this part. So please don't take my order of operations, my tooling. This is just an example for this particular part for obvious reasons. So that won't be applicable. Every part's different, every setup's different. So but if you follow the rules that we spoke about at the start of the video and go through that thought process that I've just been through there, and I know I've just done this live on camera, I will be doing my sitting down and laying this out on paper properly, and if I come to a different conclusion when I do that, you'll see that in the make video. But that was me just doing this right off the cuff without any preparation. I was thinking that out loud. I've done no forethought on that. That's me just staring at it live as I've recorded the video. So with all that being said, I'm going to bring you back to the board just now, and we'll just do a little bit of reflection and close this video out. Okay guys, that brings us almost to the end. So just a very quick reflection on everything we've just been through there, and apologies, I hope that's made sense. I feel like I've kind of rushed through. Really, I could, my regulars know me well enough, I could just bang on about this stuff infinitum, and it's difficult to get that into a 20-minute, half-an-hour video, so I do apologise if any of that was confusing, but key points for reflection. I think of all the things we've spoken about for the home shop people, my key 3 points of all of that noise that we've just been through is plan ahead, absolutely vital. Plan out on paper. Do your thinking up front before you start a job. That's key point number 1. Key point number 2, check you've got everything before you start. Yeah, so we've touched on that one already, so go around, eyeball everything, make sure you've got it. I'm going to go key 4 points actually, not 3. So 3rd point is, so you've done your planning, you've checked you've got everything, follow your plan. That's the next one that's absolutely key. Follow your plan. And then the 4th point is probably, as we said on the board for the home shop, the 4th point is verify. Now in a home shop you can't always do that. You've not always got somebody you can bounce ideas off. You've probably not got a fancy CAD CAM system that you can lay it all out in. Tip, something I do quite regularly, come into the shop, have a look at the parts, do some forward planning on paper, go and sleep on it. and I do that quite regularly. Go and sleep on it, come back out the next day. You'll probably find in that 24 hours thinking time, you'll come back and look at what you've already done and go, that's a bit silly, why have I done that? So just putting that gap in between your planning and actually starting just gives you that bit of time to do that self-verification that you've thought this through properly and you've not missed anything and you've got the key bits down. So that's probably it. I hope that's been helpful. Bit of a strange one this, it's not probably going to be everybody's cup of tea, but I do hope somebody out there gets some value out of it. I'm certainly hoping I'm going to get some value out of it when I try and remake this thing, and hope we have more success remaking it from scratch than we did trying to modify it, because that didn't go particularly well. So as I said, hope you've enjoyed that. Thank you all for watching. Thank you to the subscribers and the new subscribers that are coming along, and we will catch you all very soon on another video when we'll probably be having a crack at this thing.